Hey guys, and welcome back. If you've just tuned in, this is Tenfold Live and we are focusing on analytical geometry for matric. If you guys have just tuned in, we're a lovely show that are here to help you ace your matric. We're going to cover some great questions today. We've still got some questions left over. They're sent in from you guys, and we are proud to be sponsored by Liberty. Without them and without you, we would not be here. So guys, continue to send in your questions. We love helping you. For now, we have another question from Moya. It's a really integral question, so I'm really glad that this got sent in. Let's check it out.
Hi guys, may you please assist me with the question paper, and my name is Moya.
Okay, so a lot of teachers, guys, when you get analytical or Euclidean geometry questions, they say focus on that love letter from your examiner or from your teacher. That's basically that whole description in front of the diagram that tells you important stuff about your geometry. Okay, so this love letter is pretty involved, so I'm going to go through it slowly so we can interpret it together, and hopefully I can help you understand and maybe apply a little bit more of your knowledge than you thought was even there. So let's read this letter. It says points P at -3 and -3 and Q at 3 and -6 are in the Cartesian plane. They lie on the line y is equal to a -½ x minus 4½, and also R is the point at 2, 2. S is the foot of the perpendicular from R on PQ. Show by calculation that the circle with center S and radius SR has the equation, and that whole mess over there is the equation for the circle. Okay, so for this first line, we need to know that they are points that lie on this line. Okay, so they are collinear. They are both defined by that equation. Next, they say that this is a sundry point. They don't specify that it lies on this line. Okay, so that's the reason I've put this Cartesian plane here, to try and help you guys visualize this. Okay, so P is at -3, -3, so I'm going to put it about there. -3, -3, and Q is at 3 and -6, so that'll be about down here. 3, -6. Okay, so these guys are joined by the same line, which is defined by that equation that was given to us up top. Then they say that R sits at point 2, 2. Okay, so that is the interpretation of the first half. Now it says S is the foot of the perpendicular from R on PQ. Okay, guys, so that means that if I draw a line from R to PQ that is perpendicular to it, and I'm getting really messy here, so I'm going to get P out of the way there. P sits there. Okay, so that is perpendicular over there. Okay, so that S is the foot there. And they're saying that S is the center of the circle that basically has this length RS as the radius. So it's going to be like this whole huge circle that goes around there, and S is the center. Okay, I'm going to take that ugly circle out. I just wanted you to visualize it. Okay, so that's the interpretation of that. So it says show by calculation that the circle with center S, that's important. S is the center. Okay, so remember guys, when you're dealing with a circle, you have x minus the x at the center plus y minus the y at the center, so all squared, is equal to the radius squared. So if we wanted to interpret it in terms of that question, we get x minus x at point S squared plus y minus y at point S squared. And it said specifically that SR is the radius. Okay, so we need to find SR to determine the radius. And we also need to find point S's coordinates. Okay. Last important thing, because this is perpendicular, the tangents of those things, or the gradients, guys, the product of their gradients, MPQ, is equal to -1 because they're perpendicular. Okay, so guys, whenever you get a question like this, you need to make sure that you take note of the really important facts. If you see perpendicular, immediately think, if I multiply the gradients of those two lines, I'm going to get -1. Also, if you see center of circle and radius and all of that stuff, remember your analytical equation for the circle and take note of which point is the center, because that's going to get you that whole equation. Okay, so let's carry on with this question. I'm going to use the fact that I said that MRS multiplied by M of PQ is equal to -1. Let me get this in the right color. Okay, so if we try and take those as a consideration, if we say M of RS, which is going to give us 2 minus Y at S over 2 minus X at S, multiplied by P was given to us at -3, -3. So we get -6 minus -3 all over 3 minus -3. And that all gives us that -1. Okay, so let's continue to simplify this. We get 2 minus ys over 2 minus xs multiplied by -6 minus -3 is -3 all over 3 plus 3 is 6, and that gives us -1. Okay, so I'm going to move that down to the bottom here because otherwise I'm going to run out of space. Okay, so let me double check this. 2 minus ys over 2 minus xs multiplied by, we said -3 over 6, which simplifies to -1/2, is equal to -1. Okay, so that's basically saying that 2 minus y of s over 2 minus x of s is equal to 2. Okay, now I want to try and isolate one of these coordinates so that I can express it in terms of that, because we're going to use simultaneous equations to solve for these coordinates. So I'm going to also isolate y at s is equal to 2 multiplied by the denominator, which gives us 2 minus y of s is equal to 4 minus 2x at s. If we keep on going, we say that -y at s is equal to 4 minus 2 is 2 minus 2x at s, which means that positive y of s is equal to 2x at s minus 2. Okay, so that gives us one equation. Now we need to try and establish another one. Well, that is given to us very simply saying that s, guys, lies on this line here, which means it is defined by this equation here. Okay, so it was -1/2x minus 4.5. Okay, so remember that second equation, y is equal to -1/2x minus 4.5. That's our second equation. So now we can equate this part here to this part there because they're both in terms of y. So 2 multiplied by x of s minus 2 is equal to a -1/2 of x at s minus 4.5, which is also 9 over 2. Okay, let's continue to solve for x. So we're going to say 2x plus 1/2x is 2.5x. And then if we take this to the other side here, we get -9 over 2 plus 2 with a denominator of 2 is 4 over 2. So we get that 2.5x is equal to -5 over 2, which is the same as -2.5, which means that x is equal to -1. So the x coordinate at s is equal to -1. Okay, I'm going to severely run out of time with this, guys, but I'm going to carry on going, and then I will explain how you would go about the rest of the stuff if I start running out of time. Okay, so in order to find the y value for s, remember that it sits on this line. So we simply substitute x into that ratio or that equation. So we get y is equal to -1/2, multiply that x, and it was minus 4.5. So we get it is equal to 1/2 minus 9 over 2. So we get -8 over 2. Okay, so that is that point there. Okay, so now That has given us our coordinates of the circle, or the center of the circle. Okay, so that's easy peasy. Now we need to find the radius. So I'm going to write out the equation of our circle in terms of these coordinates, and then we're going to find the radius, and that will give us the whole equation of the circle. Okay, so let me look at this. This simplifies to -4. I've just realized that. Okay, so -8/2 is -4. So in terms of our analytical expression of a circle, we're going to have x minus -1, which is +1 squared, plus y plus 4 squared is equal to r squared. Okay, so what we were required to prove, guys, we've got this first half here. Now, because I'm running out of time, I'm not going to be able to do the second half. But we've got that first half. We found the center of the circle. We can put it into our coordinate geometry, etc. Now all you have to do is find the distance of RS and square it, and you get the second half of that equation. Easy peasy distance formula, so simple. Really great question. It helps you apply everything, guys. For now, we're going to jump into our last ad break, and then I'm going to take the last question. It's been such a joy being with you guys. Stay tuned, let your brains relax a bit in this ad, and we will see you soon.